Okie dokie. Here we go. We're doing the last two probability questions. So, if the cafeteria serves noodles, there's an 80% chance, well, you can read the problem. What do you think about the one right above it that we did last time. What do you think that we ought to do with this problem? Make a tree. Yep, we're gonna make a tree. And when we make the tree, we first of all have to figure out what are the things going on in the problem. So we've got salad and noodles. Okay, so what ultimately, after all the words and all that, ultimately, what is the question? Find the probability that they will serve salad. So that's the last part of the tree. So we're going to start with noodles and no noodles. Whatever the question is, the final question, that goes on the bottom. So noodles comes first, then we have salad and no salad, and salad and no salad, okay? Now we're going to start filling in the numbers. So be careful, pay attention to your tree. If we serve noodles, so it's right here, this is noodles, there's an 80% chance I'll serve salad. And as soon as I put a .80 here, I'm going to put a .20 here, .2. If we don't serve noodles, no noodles, there's a 50% chance for both salad and not salad. We serve noodles once each school week. What does that mean? 1/5 is the noodles, and 4/5 is the no noodles. Now, if you would rather make those into decimals, that's fine. 1/5 is 20%. You can do that on your calculator, or hopefully you just know 1 out of 5 is 20%. So if it's easier for you, it doesn't matter. To get the answer to the question, which is find the probability I'm going to serve salad, I'm going to multiply these. So noodles and salad is 1/5 times 0.80. Or no noodles and salad is 4/5 times 0.50. So I just type that in on my calculator, and I get 0.16 plus 0.40. Did you get 0.56? There's a 56% chance that I will serve noodles, or salad. I'll serve salad. All right, last one. What's happening in this problem? We're playing lacrosse and we're playing soccer. All right, what's the question? Find the probability of a student playing lacrosse. So we're going to start with soccer, and then we're going to have lacrosse or no lacrosse. Is everybody okay fundamentally with the structure of the tree? Okay, so here we go. If a student plays soccer, there's a 62% he'll play lacrosse. Huh?
Yes.
You reading it for me?
Yeah.
Okay, thank you, appreciate that. Always willing to step in. The probability that he plays lacrosse if he doesn't play soccer is 48. probability of a student playing soccer is 70. And then what the probability of lacrosse. I got 0.578 for my final answer. Does that seem good to everyone? Is that okay? And that finishes up our 9.3 notes. So that homework will be due on Thursday. There are two of them, by the way. There's a 9.31 and a 9.32, and they are both due on Thursday, okay? It's not overwhelming, you can do it, trust me. Now, here's some review that might actually help you do some of those problems. So we're gonna go through this review. All right, here we go. There are 4 boys and 6 girls in the group. If I choose 4 students, what is the probability that I'll get exactly 1 boy? Now, yesterday or the day before, we did a whole bunch of card problems where we were like, what's the probability if I choose 4 cards of getting, 2 jacks and 2 tens or something like that? This is the exact same problem. If I want exactly 1 boy, what does that mean I want? I'm picking 4 kids. 1 boy would be 4C1, and 3 girls would be 6C3. Remember, you're picking 4 students, right? Why is your hand up?
Can I have paper?
Come get one. That's what happens when you come wandering in late. Now, 4 boys, I'm going to pick 1. 6 girls, I'm going to pick 3. But it's a probability question. So what's my denominator? How many total kids are there? How many total kids am I picking?
4.
That's your denominator. Your numerator is specific to what you want. Your denominator is what it is. Now, we aren't going to take time to type all these in. Your quiz won't have as many problems, so you'll type each one of them in. I trust at this point y'all know how to do that. If you don't, we have office hours tomorrow and you better get it figured out. Okay, next. Still choosing 4 students. So guess what? My denominator is still that. My denominator is going to be that every time I pick 4 kids from this group. What is the probability I'll get at least 1 boy? Okay, now what was this? This was exactly 1 boy. So what does at least 1 boy mean? It could be this, or it could be
64.
2 boys, or it could be 3 boys or 4 boys. Oh my gosh, I can do that. What might be easier? 1 minus what I don't want. Now, what don't I want? I don't want all girls, right? I want at least 1 boy. So the only thing I don't want is no boys. So that would be 4C0, technically. You never have to include the 0, but you can if it helps you make sense. 6C4. Because what do I not want? I do not want all girls, all boys. No, I do not want all girls. I want at least one boy. So I am going to take 1 minus the probability of no boys and 4 girls. And that will give me my answer. If you're baffled by that, then your only other alternative is to do each of these individual cases. Which you can do that, just takes a while. Okay. What is the probability that I'll get more girls than boys? Okay, so stop a minute and think. What does that mean? What does more girls than boys mean? I'm picking 4 kids. If I want more girls than boys, what do I have to have?
3 girls.
I have to have 3 girls, or I have to have 4 girls, right? So what does 3 girls look like? 6C3 times 4C1, because if you're picking 4 and 3 of them are girls, then don't you have to have a boy in there? 4 girls would be 6C4, and I'm gonna go ahead and throw in 4C0. You don't need to ever. When there's a 0, you never have to include that, but it helps me remember I have to do girls and boys. What does the OR tell me to do? Add. Yep. And that will be the answer to C. All right, if Jackson has math tomorrow, there's an 87% chance he'll do his homework. If he doesn't, there's this. If a probably this, probably he will do his homework. How are we gonna set this up? Ay, we just did some. Isn't this a tree problem? And since the question is about doing homework, I'm going to start with math and no math. And then the last level will be homework and no homework. Okay guys, I'm not going to be standing up here guiding you through the problems tomorrow. You got it. That feels like a tree diagram. When you read that problem, that needs to feel like, oh yeah. Okay, so what have I got? If he has math, there's an 87 and a 13. If he doesn't have math, there's a 31 and a 69. Probability we have math is 80. Here we go. What are we going to do? We want the total probability. The total.
0.8 times 0.87 plus 0.2 times 0.31.
All right, I definitely did something wrong. All right, did you get 0.758? What is the probability of drawing both the king and queen of spades if you draw 4 cards from a standard deck? Now you guys, this is just like the boy-girl problem. This is exactly the same kind of problem. You got a group of things, in this case cards, you're picking a few out. What's your denominator? This is a probability question. What's the denominator? How many total cards? 52. How many are you picking? 52C4. Now, what do we want? Specifically, what do we want? We want the king of spades. How many of those are in the deck? And you want him. That's the king of spades. And we want the queen. There's one of her too. And we want 2 other random cards and we don't care what they are. So we're picking 2 out of how many?
50.
50. 50. We already pulled out the queen and king of spades, they're out. So there are 50 left, and from those 50, I am picking 2.
Do you not have to use P in that one?
What?
Do you not have to use P?
No.
Because like, what are the ones that you have to use P?
None of these.
None
It's
of
very rare, it's
Okay.
very rare. It happened in that one problem yesterday,
them?
but it's very rare.
Okay.
All right, find the probability of rolling 2 4s in 6 rolls of a die. Okay, I want you to think about what's happening. I'm gonna roll the die 1, 2, 6 times, right? And what do I want to have happen? I want 2 of those to be 4s. Now, do I care which 2? So I have 6 rolls, and 2 of them are going to be picked as winners. Every time I roll that die, I'm either going to get a 4 or I'm not going to get a 4. Would you agree with me?
Yeah.
What's the probability I get a 4? 1 out of 6. What's the probability I don't get a 4? 5, 6. In this problem, I want 2 4s and 4 not 4s, and that's the answer to the question. Multiply it all together, and that will be the answer. That is exactly like number 5. I mean, the setup. Number 5 is different numbers and stuff, but the setup is the same. What's happening in question number 5? I have 10 questions. So it's like 10 rolls of the die. Okay? Every time I answer one of those questions, I'm either going to get it right or I am going to get it wrong. What's the probability I get it right? 1/5. And the probability I get it wrong is 4/5. Multiple choice A, B, C, D, E. I guess 1/5. Now, what am I looking for? I want to get more than 1 right. Now, there's 10 questions. What does more than 1 right mean? I get 2 right, or 3, or 4, or 5. I do not want to do this problem, because isn't it a whole bunch of problems? So stop and think. What do you not want? You want to get either 2 or 3 or 4 or 5 or da da da. What do you not want to get? 1 or none. So why don't we do the probability of 1 right and 9 wrong, and the probability of none right and 10 wrong? Isn't this what I don't want?
Yeah.
So if I do 1 minus these, will that do it for me? Okay, so what does 1 right and 9 wrong look like? Remember, I'm rolling this die, actually I'm guessing, but it's like rolling, I'm guessing each time. I'm doing it 10 times, and I want one of them to be right. So of my 10 guesses, I want one of them to be right. You already told me the probability of right is 1/5, and the probability of wrong is 4/5. So 1 of the 1/5 and 9 of the 4/5. What would none right look like? 10C0, 1/5 to the 0, and 4/5 to the 10. Now again, anytime a 0 is involved, you do not need to write it down, but it kind of keeps the problem looking symmetric, if you put it in there, but you don't need those. That's 1, and that's 1. So you're going to go ahead and add those up. subtract it from 1. Because our job was to find the probability of getting 2 or more right. So this is 0 and 1, get rid of those options, and then that'll go like those. Okay? Okay. Number 6, I messed that problem up. I'm gonna show you how to do it, but I did not choose wisely on my numbers. So what I'm doing now is gonna look a little like overkill, but this is how you should do the problem when it is better designed. You walk into the room, somebody says pick a ball out of the jar. The first thing you have to do is decide which jar you're gonna pick it out of. Right, here's 2 jars. I say pick a ball out of the jar. Don't you have to decide which jar you want? So get 50-50, I mean, they're both the same. So 1/2, 1/2 for jar 1, jar 2. And then you're gonna pick a ball out of the jar, and the ball is either gonna be red or blue. In jar 1, there are 8 balls. 3 of them are red and 5 of them are blue. So since there are 8 altogether, the probability of red is 3/8 and blue is 5/8. And this is what makes the problem so simplistic. Jar 2 contains the same number of balls, only there's 6 reds and 2 blues. I should have made jar 2 contain a different number of balls. But this is how you do the problem regardless. All right, I want to know the probability of drawing a red one. What's the probability of drawing a red ball?
0.
Well, what's the probability of drawing a red ball out of this jar?
0.5 times 3.
Uh-huh. So that would be 3/16 if I multiplied the fractions. And then this one would be 6/16. And again, you can do this on your calculator, I don't care. And then what are you gonna do with those 2 numbers? Add them. So the probability of getting a red ball is 9/16. And that's how you can do this problem. Even if this jar had 20 balls in it. This is the setup that you would do. You each jar separately and add them together. All right, number 7, read the problem and tell me what your thought is as far as a strategy. What's your strategy here? Venn diagram, perfect. Anytime, guys, that you have A's and B's overlapping each other, that's a Venn diagram. So we know the probability of A is 0.74, the probability of B is 0.42, and the probability of A and B, this is the correct notation. I couldn't find the upside down U on the typewriter or on the computer, so I'll put it in here. That is 0.32. So in terms of your picture, the only thing you can fill in right off the bat is right here, okay everyone? That's what we can put in right away. That's the overlap. Once we fill that in, then we can figure out what this section is. Because the whole circle is 0.74, but you've already accounted for 0.32 of it. Is this 0.42? Okay, but that has nothing to do with this 0.42. That is coincidence. This whole circle, is that 0.42? So this is 0.10? Now, what do those add up to? 0.84. Which means there's 0.16 out here. Question A, what's the probability of not A and B? What's the answer to that first question? 0.10. You like bananas, but you don't like apples, so you're in the B ball, but you're not in the A ball. What's B? The answer to B. Those are the people that don't like either one, so that's your 0.16, agree? And then the probability of A given B. Okay, you need to know your little formula for this. Anybody remember it by chance? Okay, it's the probability of both. So the numerator, this is gonna be a fraction, and it's the probability of both over the probability of B. So it's A and B over B. This means given. So this is the probability of A given B. All right, now luckily, both of these numbers were given to you. You don't need to figure these out. They're given to you. The probability of A and B is 0.32. And the probability of B is 0.42. So whatever that is in reduced form, uh, 16/21st, if you reduce the fraction. I guess I could have done that. 16 over 21 or whatever decimal that is. All right, let's hurry up and get this. We'll do one more and then we'll have to do lunch. I've got to get done with this. All right, number 8. Look at the problem, read all that stuff, and tell me how you think we ought to do this. A Venn diagram. And again, the way it clues me in, and you all have your own ways of thinking about it, but aren't there sets of people who are overlapping each other? Like apples and bananas, they're overlapping. And whenever I have that situation, I like to at least start with a Venn diagram. Now, what is happening in this Venn diagram? Aren't there 3 things going on? We have basketball, volleyball, and soccer. So you get 100 kids all together. 32 of them like basketball. Do not put a 32 in this picture. 29 of them like volleyball. 53 of them like soccer. Now, 2 like all 3. I can put that in my picture. That's these guys right here. 22 like only basketball. 18 like only volleyball. And 40 like only soccer. Before I can answer the questions, I need to fill in my Venn diagram. All right, so how do we do this? I think we did this yesterday or the day before. Yeah, put in some variables. I usually use X, Y, and Z, but use whatever you want, because you somehow have to figure out what those missing sections are. All right, so one ball at a time. 22 plus 2 plus X plus Y has to add up to 32. That's my basketball ball. 18 plus 2 plus Y plus Z has to add up to my volleyball, 29. And 2 plus 40 plus X plus Z has to add up to 53. Now, is everybody okay with those beginning equations? All right, let's clean them up. So this makes 24, so X plus Y must equal 8. This makes 20, so Y plus Z must be 9. This makes 42, so X plus Z must be 11. Does that look all right? Now, pick any two and eliminate the variable they have in common. you decide to eliminate in these top two, you would be eliminating the y's, agreed? So I'm gonna go ahead and multiply this by a negative, and I'm gonna add them together. So these are gonna cancel. So I have x minus z equals -1. But down here, I have x plus z equals 11. That was my last equation. So what does that mean? 2x equals 10, so x equals 5. And if x is 5, then y must be 3. And if x is 5, z must be 6. Agreed? Answer the questions real quick. Go, grab a kid. Reach in the box, grab a kid. 100 of them. Probability is something out of 100. Likes only volleyball and soccer. Only volleyball and soccer would be which kids? 6. 6 out of 100. Doesn't like any of them.
4.
Oh, how did you do that?
I added them all up.
You add all these up, you got 96. So there's 4 out here. I didn't do that myself. I'm trusting Jake. Could be a mistake. I'm not sure. So your probability would be 4. Okay? All right, it gets 3 minutes later. The correction is 53. Back at 53.